All right, so let's get into some of this code here and let's understand what's going on. So um, we have a bunch of hexadecimal arrays which represent the pictures to draw. In order to draw these, it's really simple. You essentially go on Pascal.com or something and you draw a 32 by 32 background, convert it to a C array, and then use that array in C as the array for this. And in order to actually draw it, um, let's just go over here. Yep. And then, yeah, so over here we want, basically it's the same for every array. I'm just going to show it for the main background. You get the display address, you get the background, then you have a counter here, and then you do a loop, which gets the ith value or the t3th value of the background, and then plots it and stores it, and then you keep looping until you've done it 1,024 times because, yeah, there's 1,024 pixels. But yeah, that's not interesting. That's just the basic drawing stuff. Let's get into the actual information about the user itself. So we start off with 3 lives. We have our default position of which we draw the car, and we have these. So this is a good concept to discuss because this really helps us with collision, and I'll explain why. So let's restart the game. Let's go into slow mode just so we can see an easy and clear example. And let's go at the very left. So I'm at the very left, and I wanna understand how many times I can move to the right. So count with me: 1, 2, 3. So at most, this car can move to the right 3 times. And similarly with up and down, it can go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times, right? So why am I telling you this information? It's going to come very much in handy when I begin to explain the game loop, right? And by the way, when I collide with something, all these values get defaulted back to their original values. So for example, because these values work with the default position. So whenever I collide, I just revert all these values and then move it back. And then now I can explain how the main loop works. So yeah, before we go into the game loop, we draw our intro and then we check for keyboard changes, so on and so forth. And then we go into our game loop, right? So we check the amount of lives and then we check if we're at 0. If we're at 0 lives, then it's game over. And then we do, yeah, we check the actual values of where we are, left, right, up, and down, and we see if we're out of bounds, right? Because if I can move at most 11 times, if I'm at 12 and it increments to 12, then I know I've lost a life, so I have to go back again, and one of the lives gets decremented. And that's essentially what lose life does. It reverts all the values and it decrements the amount of lives. And this is also good for other collision detections, right? So for the down car 1 and all these are enemy cars in their starting positions, and we check if they're equal to our current pixel number, or our starting point of where to draw. We compare the two starting points of where to draw and see if they're equal. We do this for all the cars, and if all of that is good, then we check for keyboard changes, and then we update all the cars. So when I'm moving left to right, I'm increasing it by 32 or decreasing it by 32 pixels, or yeah, 30, 32 bits or pixels. And for up and down, it's 256 and minus 256. After that, we update the positions of the cars, and then we draw all the cars, right? So we draw the enemy car 1, draw the enemy car 2, draw the enemy car 3, draw the enemy car 4, and then we draw our car. Then we sleep, draw the background, and then game loop, right? So yeah, this is the overall loop of how the game works. I just before I finish this off, I just want to show again I just want to show how the actual car moves. So over here, after we listen to keyboard changes, then we update the car, and then depending on which, oh sorry, actually before I go into the user car, yeah. So for the enemy cars, we oh, wait, yeah, sorry, for the enemy cars, we check if they're equal to a certain pixel, which represents the amount of movements before entering the safe zone. And for example, for the car on the very left, we're only going to do by minus 128. But for the other car in the same lane, for the one lane over, we're going to do it by 256, right? So it's going to move at two completely different rates. And same thing for the second half of the board is 256 and then 128. So this is really how you determine different cars moving at different speeds. It's just how much you want to draw or how much you want to increment it or decrement it before we redraw it. And so now I'll go to the user-controlled car. So just yet again, kind of the same logic. Once a key presses happen, we check what we pressed. So this is A, this is I believe this is W, this is S, and this is D. And depending on those, we have our separate functions which tell us exactly what to do. We go into we do another couple of checks just to make sure that we're not going out of bounds, being very cautious. And then let's go for so if for draw S, that's going down. So now we're going to add 256 because we're increasing 256. Drawing so for W, that's going up. We're incrementing, so we're going up 256, but in assembly you have to do minus 256. Draw D, which is going to the right, we increase by 32, and then going A, we decrease by 32. And given all this creates a really nice, well-functioning game that works. And yeah, try it out yourself. Take a look at some of the more functions. All of them are pretty obvious in terms of what to do. The functions themselves kind of tell what happens. Actually, before I go, I'll show you how lose live works. So yeah, literally all lose live does, just in case there's any more confusion on it, we load the address of all the values, we load the words, and then we just reset it to the original value. So remember, this was 2, this was the original, if you remember from earlier, this is the original position of where we start at. And for the lives, so we load in the lives, and then we store it in the offset, and then we store the offset into T2, and then we decrement, and then we store it back into the original, right? And then so on and so forth. Then we sleep for like a tiny bit, and then we jump back to the return address. And that's about it. So I've explained how do we draw the background, how we draw the logic, how we detect collision, and how we draw the cars themselves. So if there's any other questions, feel free to look more into the code because all of it's pretty self-explanatory. And thank you so much and have a great day.